AI just invented 106 AI models, which is crazy. This is a very big scale automated AI research by AI. It's all explained in this new paper. Humans are very slow, and if we can automate humans with computers, computers can be a lot faster in AI research. So they propose artificial superintelligence for AI research. Now, honestly, I think this is just a first step, so it will take a few years for this to happen. But I think it's very good that we have these ideas starting to pop out. So what we learned from AlphaGo is that if we are able to design a small limited system with clear rules, and if we have a good exploration mechanism to explore different strategies, not just naively try every strategy because there is too many, but if we have some good exploration mechanism, it can learn more than humans can teach it. Because even though humans would explore in even smarter way than AI, but humans are a lot slower. So the idea here is we need to somehow design a system that's constrained and a good search algorithm, and then it can learn better than humans. And currently we do just have automated optimization, where AI is just trying a few different changes in a few different numbers. But the next step would be automated innovation, so not just a few numbers, a few experiments, but the whole abstract ideas and the taste and the feeling for what could be the good research direction and good architecture. But this is all happening in maybe 4 years, not earlier, because it also makes sense that these companies like Meta are buying researchers and giving them 4-year contracts. So maybe because they expect AI research to be automated in 4 years. So it discovered 106 innovative state-of-the-art, I don't know if they are the best architectures, but maybe they are close to best, of linear attention. And you can click here GitHub repository and model gallery. So they open source all 106 discovered, and you can see here the scores, the architectures, and everything of those models. The main reason this paper is good is because it establishes baseline and it starts digging into this field of automated AI research. So let's look at one of the architectures, and it's very interesting how it does it. So it has input, linear layers, convolutional, L2 norm. Actually, the architecture is pretty interesting. I'm surprised that they managed to generate all of this. So they did 1,700 autonomous experiments and spent 20,000 GPU hours to get 106 innovative state-of-the-art linear attention architectures. So they also established a new scaling law, or I should call this scaling observation. These are not laws, any of them. But anyways, it means the more GPU hours you put in, the better the score on this benchmark, whatever the benchmark was. We still need to wait for other AI companies or labs to replicate this, but if this gets replicated, it's very good. We want these scaling systems that when you put more compute, it performs better. We want those things are good. This is how it works, and I think it's really good. So first it searches these AI papers and code and knowledge. And I think this agent setup is really good because if you watch one of my previous videos where they just used basic Gemini Pro to solve 5 out of 6 math Olympiad questions that it never saw. So a bunch of agents working together, it's very powerful. So then they extract all of this knowledge. So we have a researcher and engineer systems working together. And this is composed of multiple agents and prompts. And this is also composed of multiple agents. And so this researcher and engineer are getting the existing knowledge from the internet and from this analyst that is reviewing their output. So this is self-recursive, and this is the existing outside knowledge. I really like this because if this agentic workflow is set up well, it can really work well, because we just had basic Gemini 2.5 Pro solve get gold medal in Math Olympiad, so it's really good. So we got this proposal of the research, code implementation, and then novelty and validity check. And after researcher loops, then we have different set of agents. Engineer. So this guy will code, it will maybe improve the code, it will also have its own novelty, efficiency, complexity check. it will have more judgments. These judgments are always good. You tell the guy who generated to check it, you tell a different agent to check it, and then you tell whatever this guy checked by a different agent. This is always good. This is just allowing LLM that has limited output token window to basically have a lot more output tokens, a lot more place to think. So this agent outputs something, then we put that into context window, when they output something else, and we put that into context window, output something, and that's how it recursively improves. And that's how you give it basically infinite time to think. And maybe Gemini 2.5 Pro and Claude Opus or Claude Sonnet would be maybe best for this. But so Gemini for thinking, Claude for coding. I know there are AI researchers and students and enthusiasts who are watching me, and if you want to do some research, this is really good idea to try this, to try the re-implementing, and you can use cheaper models, smaller scale. You don't need to spend so much money. Or you can do it for free, I'm pretty sure. So for example, I would question the necessity of this fitness score, because they are putting whole feedback into a single score. In my experience, maybe it's good for them, but in my experience didn't work well. So what I would do is I would just give all of this feedback to this entire, the whole text to analyst, and then tell it to produce feedback and then feedback here. So the whole idea here is you have a bunch of different agents and you give them infinite context window for thinking, and that's it. So of course the engineer is doing the experiments, so it gives like loss motivation code and etc. So they do give all of the results as well, I'm pretty sure. So there is this nice workflow. If you want, you can read this. So this is how the exploration works. In the beginning here, we have some architecture. They call it delta net. And light colors means it's not performing so well, and red means very low performance, while dark blue means very good performance. So in the beginning, a lot of them have these lower scores. So they use ones with good scores, the blue ones, and create children, create other variations of those. And as you can see, more and more are dark blue, which means more and more architectures are performing better as we go down the tree. And in the end, we have a bunch of these good architectures. So 1,700 explored architectures here. Here they have this evolution tree. You can just check like the names of the architectures. I'm gonna zoom a little bit. So they have different ways of generating these architectures, of doing the search. And a few of the ways get most of the results. So a few best ways. For example, gating system. The red one, 14% accepted and less than 14 rejected. So these beginning systems, they yield most of the good architectures, the red lines. While some of the search methods or design methods don't yield any good architectures in the top 106. Here we can see the number of samples. This graph is tracking the average performance of the top 50 models. So top 50 best models, and we can see as we have more samples, more steps, more exploration, the loss goes down, which is good, and the raw benchmark score goes up. And their fitness score that they evaluate, it also keeps improving. So this figure is showing that the model is not cheating by just adding more parameters to make the models better. But you see here, the number of parameters stays low over all of the samples and explorations. Here we have some benchmarks. They're comparing it to Mamba 2, DeltaNet, etc. I think it's pretty reasonable to compare to these models because, as I said, these are just first steps in this automated system. It's not going to be better than Gemini 2.5 Pro and stuff. So, and they are performing well. And crucial, they are all made from this model and they are performing better than that model. So that's the self-improvement, recursive self-improvement. That's it for this video. It's very interesting. Check out my other videos and see you next time.